All right, Math 3, we are going to start section 7.3, logarithmic functions. Now, this will be new to you, so it'll be a little confusing at first, but you do have a log button in your calculator, and we're going to be doing it by hand and do some using a calculator. If it were me, I would probably go ahead and read through on page 525, read on page 525 to kind of grasp what this is all saying. It's a lot of letters in here. But we're going to be dealing with these logarithms, and this will be how it is written, and this is how you say it. So if it's log, and there's a 5 here, you'd say log base 5 of x. We deal with log base 10 systems, all right? You don't have to do anything fancy with log base 10. Your calculator is programmed to do log base 10. So if it's log base 5, then we have to find another way to do it in our calculator. Now, the reason we're learning logarithms in this section is because, as you know, everything has an inverse operation, like multiplication and division are inverses. Square and square roots are inverse. Adding, subtracting, square, those are inverses. Well, exponents, which we just finished doing our exponent graph, and logarithms are inverses of one another. Okay, so they're showing you, that's kind of what they're talking about down here and here. They're talking about doing inverses where you switch your x and your y and you solve, things like that. This is something probably to point out down here. If you have something like this where these are numbers, so you'll have 5 log 5 of 3. Well, your answer is 3. If you have log base 5 of 5 to the third power, well, your answer is 3. All right, so they're showing you that's because they're inverses of one another. Again, if you take 2 times 5 and you get 10, okay, so this is what I'm dealing with. 2 times 5 is 10. Well, if I turn around and I divide by 2, I'm going to get right back to here because multiplying by 2 and dividing by 2 gets me right back to the same answer, and that's what this is saying here. If you have b to the exponent of log b to the a, well, your answer is a. If you have log base b of b to the a power, well, your answer is still a. You're doing the inverse operations. All right, so if you want to go ahead and turn over to page 526, we'll go through some examples together here and see what we can come up with. All right, so on 526, it asks, what is the logarithmic form of each equation? All right, so it says you can use the definition of a logarithm to write exponential equations in logarithmic form. All right, so we agree that 6 squared is 36. So what they're wanting you to do is to write that into logarithmic form. So the way you do that is you'll say log base 6 of 36 is 2. So log base 6 of 36 is 2. All right, now where did that come from? That came from over here. Let me find it. Like if you have something like this, it can be written like this. All right, so that's kind of how you're going to be writing. It's a lot easier. Let's jump down to the bottom of page 526, and we'll do that first. Find the value of each one. So we want to know what each of these equal, okay? And the trick that I learned when I was learning these is you do this like little snail, like a loop-de-loop. So you take this 5, you loop it around, and you go to here. So you say 5 to what power is 125. You loop it around. All right, so, and then I change it into an exponential form, which we know how to solve. Okay, so it's the same thing here. If I take my answer that I have in log form, and I do that little loop like that, don't I get 6 squared is equal to 36? Well, that's what this says. So that's how you're going to be doing that. Okay, so here we go. We're going to do the same thing. So log, whatever this is what goes here. So log base 2/3. All right, and then you're going to take your answer of 8/27 is equal to 3, which means that 2/3, I'm going to loop that around, 2/3 to the third power is equal to 8/27. All right, so why don't you go ahead and give this one a shot, the same way we do it with all the other ones. All right, and then check your answer with mine. make sure that's what you have up here. So 3 to the 0 equals 1. All right, so here you'll say log of 1/3 is 27 is equal to 3 to the third power, 1/3 of the third power. Okay, we get the idea. All right, so back down to this one here. Now that we have it set up exponential, you just think 5 to the what power is 125. Well, that's 5 to the third, so x is 3 here. You're going to loop it around, so you're going to say 4 to the what power is 32. It's a great question. Let's see how... Oh, let's see. Let's do this one. 4 is really 2 squared, so it's 2x. 32 is really 2 to the 5th power, I believe. So you got to get your bases the same. We learned that in Math 1. I changed 4 to 2 squared, so that made it 2 to the 2x. I changed 32 to 2 to the 5th. You have to get your bases the same. Once you get your bases the same, you're going to set them equal. So you get x equals 5 over 2. All right, so here you will say 64 to the x power is 1 over 32. I think all of these can be written as a power of 2. So 64 is 2 to the 6th power, I believe. 2 times 2 is 4 times 2 is 8 times 2 is 16 times 2 is 32. Yeah, 2 to the 6th. All right, so I'm going to change that 64 to 2 to the 6th, but since it has an exponent x, it's that. This one, since it's a fraction, I need to flip it over. I'm going to say 2 to the negative 5th power because I'm changing it out of a fraction. And then now that my bases are the same, I set my exponents equal. So I say that, and I divide by 6, so x is equal to negative 5, 6. All right, so this one, you're going to loop it around. You're going to say 49 to the what power is 7? Well, what I would probably do, again, is change 49 to 7 squared. This is 7 to the 1st, and again, my bases are the same, so I set them equal. So I say 2x is equal to 1, which means x is equal to 1/2, which we've learned before. If you take 40, last test, we did this. If I gave you on your test, I think it was 81 was what I gave you, but if I take 49 to the 1/2 power, I'm just simply asking what is the square root of 49, which is 7. All right, last one we're going to do. So you're going to write 2 to the x power is 16. You're going to leave 2 to the x. It can't go down any further. 16 is to the 4th power. So since your bases are the same, x has to be 4. All right. If you look here, your common logarithm are your bases of 10. That is what your calculator is programmed. It shows you that you can use common logarithm right here. You simply, you don't show the 10. So if you ever just see a log, you automatically know it is base of 10. So log base 10 of x is simply written as log to the 10. So it says many physical phenomena, such as a wide range of values that reported in logarithmic or exponent forms. You got your Riker system. So you can take a look here. Your Riker system is how earthquakes are done. You look here and it will show you how that works. All right. So you're going to do a few little problems there with your Riker system. If you want to try that, you may. You can also go onto your Pearson account and it will go through and explain it a little more thoroughly. But I will tell you the got it problem, you're going to be, if you want to give that a shot, it's approximately 16 times. Don't put an X, sorry. 16 times. All right. So you can kind of look at that. All right, if you look over here, they're showing you what the graph of a logarithmic looks like. It looks very similar to your exponential graph. You remember we just did our exponential. It comes up, you remember that. It crosses at 0, 1, and then it skyrockets up. If you reflect it over, it is the inverse. And so the blue graph would be your logarithmic. Again, if it's reflecting over this line, x equals y. So it's just a mirror image over that line. All right, so exponential, logarithmic. All right, that's what that looks like. So you can kind of read through that as well. Okay, if you remember on your exponential, you had the x-axis was generally your asymptote. Here, it's going to be your y-axis. That will be your asymptote for your inverse one on your logarithmic. All right, so let's go through a graphing up here at the Got It. What it is asking us for is we need to describe the domain, the range, and the y-intercept and the asymptote. Okay, so the domain on here, you will do it's only positives, so your domain will be when x is greater than 0. If you remember on your exponential one, it only was above the x-axis, so your range was greater than 0. Here your thing is going to be your range for this will be all real numbers. If you take a look, we've crossed over the x-axis. This comes down forever on your negative part of your range, and then this will go up slowly, but it will keep going forever to get your all real numbers. There is no y-intercept on this one, and the reason being, again, is because you have this y-axis is your asymptote, so it won't cross it. And so what you do is you have that vertical asymptote. Okay, so you have the vertical asymptote is when x is equal to 0. When x is equal to 0, it's your y-axis. All right, so you have a vertical asymptote at your y-axis. All right, so let's go ahead and kind of graph this a little bit. Well, that was bad. All right. We can go through and just put a few things in. So let's say I want to do, let's put a 1 in here, okay? So basically what you're doing is you're doing log base 4 of 1. All right, so you're saying 4 to the what power is 1? Well, that is a 0, so it's going to cross that 1, 0. All right, let's do log base 4 of, can't really do 2. Let's do log base 4 of 4. I can't put a 2 here because I'm thinking I want an answer. So, you know, it's basically 4 to the what power is 4. All right, so I'm putting a 4 in for the x, and my output here, remember we're looping it around. So you're doing 4 to the what power is 4? Well, that is 1. So 4, 1 will be another point. 1, 2, 3, 4, 1. Right there. See, we could do a fourth. That would 1/4 would work. Okay, remember our x's always have to stay greater than 0. I can't do a 0. So now I'm looking at log base 4 of 1/4. So 4 to the what power is a 4th? That's -1. So when it's a 4th, I'm at -1 right here. Probably is going to be good enough. There we go. And it's going to kind of come and then come around like that. Okay, and skimmy along. Okay, so that's how you can do this. So you're just going to be using 2. So like 2 to the what power, and give me like multiples of 2 here. So start 1, 2, 4, 8, 16, things like that. So 2 to the what power gives me that. And just loop them around, okay? All right, here are your translations. They're just like anything else. If you have it involved with your x, you're shifting left and right. If you have it involved out here, you're going your vertical up and down, and it kind of talks to you about that in here. So like for an example, this one will be shifted right 3, up 4, so you'll make your normal graph, and then you'll add 3 to your x's, because you're shifting it on your x-axis 3 spaces, and then add 4 to your y and go up. So here, you're going to be just multiplying your y's by 5, so you can do your little chart like we just did, but you'll multiply your y's by 5 and go with that. Here you can do your log base 3 of x like we normally would do, and then when you're done, add 5 to all your x's, and then 3 to your y's since you have a shift in that one. All right, if you get lost and confused on your translating, go to your Desmos and kind of see if you are doing it correctly. All right, and as always, let me know if you have any questions.